Now it's time to train the the node that use the Gaussian function as the activation function. So now, okay, we can start with the same thing as we did before. That is, error is 1 by 2 target minus output square. And then when you want to find the gradient, so you have to find the partial differentiation with the blue. So it is same way that we did before. That is target minus output, and then you have to partial differentiation of these values, right? Right. So this one is 1, and it is target minus output and minus 1 here, and then this one is constant, so it is 0, so you have to partial dip the output by the blue, and the output is, so you can think that the output is e power minus w dot x square, right? Okay, so this is like diff of e power u by dx. For example, it will be d e power u and du by dx. So it is same. It will be e power u, okay, and then partial differentiation of this function, okay, by weight. Okay, so this one is, we can keep it here. This one to make it clear. Okay, so you have to dip this one, so it will be 2, right, minus w, sorry, you have to move minus here first, so it will be minus 1, and its 2 will move here, so it will be, I would like to make it better by here, and blue dot x square, right? So it will be, and minus 1 here. Okay, so this one will be 2 w dot x, so it will be x. So these values will be okay. So you have to move, this value here, so it will be, this one is also the output, right? Okay, so it will be target minus output, and you have 1 minus 1 here, and then this one is output, and this one is minus 2, and w dot x times x. So this one is constant. When you have to, when you want to adjust, you must use the ether term here also. So it is, again, it is constant. constant of 2. So it will be eta or learning rate, target minus output and w dot x and x. This is the gradient. But guys, you have to subtract this error, right? Subtract this term from the original w. So your new w here, w will be w minus target minus output and w dot x times x. So this is the values that you can use to train the Gaussian function. Okay, so that's all. We'll check this equation in using Python to train the data that you want it to be like this one. You want it to be like close to some value. Okay, like close to 1.5, but we don't need to know in advance that what is the 1.51, but you get the values, the target values and the output from your steps here, so you will be able to train and to find all weights. Let's see in the next video clip that I'll show you how can we write the program to prove that this one is true.